This is our adding and subtracting rational expressions part 2 lesson. In this one, we're going to focus on polynomial denominators. So we're going to find the sum and difference of each of these rationals. Is very similar to our last lesson, but in this case, our LCD is going to look slightly larger because we're going to, for the most part, combine both of our denominators. So in this example, our LCD is going to be p minus 2. We have to have one of those, and we also have to have p plus 1. And then our NPVs comes from our first denominator, p minus 2. We would have a problem if p was 2, and also another problem if p was negative 1, because then would have 0 in the denominator if we were to plug those numbers in. Now I'm going to rewrite our rationals just like before. And then we're going to determine what we're going to multiply top and bottom by for each rational in order to get our LCD in there. So our first rational, we're missing the p plus 1, so I'm going to multiply p plus 1 top and bottom. For the other rational, I'm going to multiply by p minus 2 top and bottom. And then now we're going to do our distribution of multiplication. So that's p times p, which is p squared, plus p minus p. This is a difference of squares, so you're not going to get a middle term, but you're going to get a constant number, which is negative 1 times 1, and that's negative 1. I'm going to leave the denominator alone. And then for our next set of rationals, we got p times p in the numerator, that's p squared. Then we get minus 2p plus 3p. 3 times negative 2 is negative 6. So again, I'm just distributing this multiplication within the brackets. I'm going to leave our denominator alone again. Now we're going to collect our like terms and put this under one denominator. So we have p squared plus p squared, which is 2p squared. Our middle term, negative 2p plus 3p, is just positive p. And then lastly, negative 1 plus negative 6 is negative 7. So you can leave your answer like this, or you can expand your denominator. We could try to factor a numerator, but you're going to find out that we actually can't. So we're just going to leave it like that. For our second one here, before I state my LCD, I'm going to factor y squared minus 4 because this is the difference of squares. So that'll be y plus 2, y minus 2. So then for our LCD, we already have the y minus 2 in common between the two rationals, but we don't have a y minus 2 in the other one, and we have to. So this is our LCD. Y plus 2, y minus 2. And then our NPV is going to come from the denominators of the LCDs. So that is y equals 2 and y equals negative 2, because if you had either or, we're going to get a 0 in our denominator. So I'm going to start out by writing out our rationals, and then we're going to multiply both of our rationals top and bottom by something to get the same LCD. So our first one here, I can actually leave this one alone because our LCD is already in there. I can actually erase that and rewrite it into factored form. It already has the LCD, so we're good to go for that one. But this one here, we do need to multiply top and bottom by y minus 2 because we're missing that one. Okay, so now I'm going to distribute the brackets in our second rational. So we got y times y, which is y squared, minus 2y plus 4. That's what we're going to get after we distribute this all over our denominator. Okay, so now we can simplify. So we got y squared plus y squared is 2y squared. Negative 2y minus 2y is negative 4y. And then lastly, negative 20 plus 4 is negative 16. Looks like we can factor our numerator. So I'm going to go ahead and do that. I'm going to factor out 2 first. And then we'll factor the numerator again, just to see if we can cancel anything out. So if I were to factor y squared minus 2y minus 8, factors of 8 are 4 and 2. And we can achieve a negative 2 for a middle term if we had a negative 4 and a positive 2. So we can see that we can cancel out this y plus 2 top and bottom. And then whatever is left over is our most simplified form. So that would be our final answer. Our next one for C. Again, we need to factor this 9 minus x squared because it's a difference of squares. This is 3 minus x, 3 plus x. So then our LCD is going to then be 3 minus x, 3 plus x. We have an x minus 3 in the very first rational, but it is so close to actually one of these, and I'm going to show you what we're going to do in order to get a 3 minus x from x minus 3. Before we do that, though, I'm going to state my NPV. I'm going to get x equals plus or minus 3, because if we were to insert x equals 3 or x minus 3, we're going to get a 0 in the denominator. Okay. So for our first rational, I'm just going to factor out a negative, and if I do that, I'm going to get a negative x plus 3. Now what I can do is just switch the spots of these, and if I did that, that would be 3 minus x. And this is one of the parts of the LCD we need. And then from here, I also need a 3 plus x. So I'm going to multiply top and bottom by 3 plus x then. For our second rational, it already has the LCD in it, so I'm just going to leave it as is. Now let's go ahead and simplify. In our numerator, we have 2 times 3. Or what I can actually do is bring this negative up with the 2, because it doesn't matter. The negative can go either in the numerator or the denominator, and it would be the same thing. So I'm going to move this negative up so we can get a negative 2 times 3, which is negative 6, and negative 2 times x, which is negative 2x. And I'll leave our denominator with the LCD. And then I'm going to just attach the other numerator, so we can just put this all under one denominator for now. So this negative 3x is just coming from our second rational. Okay, now we can simplify this. So negative 2x minus 3x is negative 5x. We still have that negative 6 there. We can't factor that numerator, so I'm just going to leave it alone, and this is what we have. We can just leave it like this, or you can write this back into our 9 minus x squared denominator if you were to expand. 2 more examples to go through. So for this one, it's a slightly different type of question just because it looks like we're going to have even larger denominators to work with. So the first thing I'm going to do is just factor our denominator before we can even tell what the LCD is. So the first denominator is a difference of squares, so it's x minus 7, x plus 7. And then our second one, factors of 49 are 7 and 7. And we can create a 14, positive 14 if they were both positive 7s. So now I can take a look and see what my LCD could be. Well, we need to have an x minus 7 and an x plus 7 for sure because of our first rational. Looking at our second rational, we have x plus 7 to the power of 2. So that means I need 2x plus 7. So in my LCD then, I'm just going to square this x plus 7 to indicate that. Then for our NPV, we have x equals 7 and x equals negative 7 because, again, if we were to insert 7 or negative 7 into either rational, we're going to get a problem with a denominator of 0. All right, so the next thing that we can do then is determine what we're going to multiply each rational by so we can get this LCD. So our first rational to multiply top and bottom by x plus 7, so we can get that x plus 7 all to the power of 2. And then for our next rational, we need to multiply this by x minus 7 because that's what we're missing. I'm going to leave the denominator alone, but I'm going to simplify our numerator. So that'll be 7 times x, which is 7x, and then 7 times 7, which is 49. Moving on to the next, I'm going to multiply 3 with x and then 3 with negative 7. Now we can collect like terms in our numerator and combine them. So 7x plus 3x is 10x, and we have 49 minus 21, which is 28. Again, I'm just going to leave our denominator alone. And that would be our final answer. One more example here. Similar concept to the one above. This one is a pretty hefty question. There's going to be a lot for us to simplify. But again, we would start off by simplifying our numerator, factoring our We're going to start off by factoring our denominator. So factors of 18, well, we need a 3 and as our middle term, so 6 times 3 is 18. If we had a positive 6 and a negative 3, you can get positive 3. And then looking at the next one, factors of 25 and 4, a positive 5 and a negative 4 would give us positive 1n. Okay, so now we're going to have to state what our LCD is. And as you can see, it looks like we're going to have to include every factor, n plus 6, n minus 3, n plus 5, and n minus 4, because there's no repeats. I'm going to write this more on the side here so I can have some room. Okay. So that means for our first rational, I'm going to multiply by n plus 5 and n minus 4, top and bottom. And then for our second rational, it's going to be n plus 6 and n minus 3, top and bottom. So I'm going to do things one at a time because it is a lot for us to simplify and expand and all that. So I'm just going to do the n plus 5 times n minus 4. We know it's this one anyway, so that's where it came from. And then for next set, I'm going to leave n minus 2 alone and then just expand this n plus 6, n minus 3, which is this one anyway, because that's where that came from. And then put this all under the same denominator, our LCD. Okay. Next, we're going to simplify the numerator more by expanding. So we're going to multiply n minus 3 with n squared plus n minus 20. And yes, it is quite a process to do, understand that. Okay, so we have n cubed. N times n is n squared minus 20n, and then negative 3 n squared, negative 3n, and then positive 60. And then I'm going to do the other one here. Put this all in brackets. So n times n squared is n cubed. N times 3n is 3n squared minus 18n, negative 2n squared, negative 2 times 3n, negative 6n, and then lastly, negative 2 times negative 18 is positive 36. Isn't that just nasty looking? So long, but we're going to shorten this by simplifying and collecting our like terms as much as possible here. Alright, so I'm just going to do the left part of it before the bracket and try to simplify that first, and then do the same thing on the right that's in the inside of that bracket. Okay, so we only have one n cubed on this left side. And again, I'm just looking from here to here right now. Then I'm going to look for n squared. We have n squared minus 3n squared, so that's negative 2n squared. Then we have negative 20n minus 3n, so that's negative 23n, and then a plus 60. For our next one, set of brackets, we have 1n cubed. For our n squared, 3n squared minus 2n squared is just n squared. Negative 18n minus 6n, negative 24n. And then we still have that positive 36 all over that LCD. Looks slightly better. Okay, so now remember this negative is going to affect everything in the bracket here. So I'm just going to write this in red. This is going to be a negative n cubed, a negative n squared, a positive 24n, and a negative 36. So we have n cubed minus n cubed, so that's just gone. Then we have negative 2n squared minus n squared, which is negative 3n squared. Negative 23n plus 24n is just positive n. Positive 60 minus 36 is 24. All over our LCD. We can see if we can try to factor a numerator, and maybe we can cancel something out. So I'm going to factor out the negative then. So let's see, 3 and 1. So it looks like we can factor this if we had a 3n plus 8 and an n minus 3. If If you want to use a different method to factor that, that's totally fine. And we would now remove this n minus 3. So this is our final answer. And that one's done. This one was a really long and nasty one, but this is the hardest it would get. If you can do this, the rest of them are easy.